Here's an example where the function in the integram's position is not undefined at one of the endpoints, but take a peek at where it is undefined. If you interpret the evaluation of this integral as the area underneath the curve, I look at the area underneath the curve as x range from 1 to 3. Well, roughly speaking, here's a 1, here's a 3. But technically speaking, the vertical asymptote is not at one of the endpoints, it's in between. And so technically speaking, it's as if I'm looking at this area here plus this area here, both of which are areas of unbounded regions, but the sum of those unbounded regions areas could be finite. So how I handle this situation is I break this up from 1 to the value of x for which I have discontinuity, plus another integral from the value of x for which I have discontinuity to the other extreme. Now that being the case, both of these are clearly improper integrals because of two unbounded regions. So I think I have the limit as x approaches, is that a root 2 from the left-hand side of this mess? Oh, sorry, wrong mess. I meant to write a definite integral within the limit. Let me do that again. The integral from 1 to, I said x. Can I choose a different value? I've already got x in my variable integration. How about a t? So 1 to t of this mess. Plus this improper integral represents the area of the unbounded region, which I think I can write as a limit. Maybe as s approaches, is that root 2 from the right-hand side of the definite integral from, let's see, that would be my s to my positive 3 of this mess. Now, if one or both of these integrals diverges, then for free, that diverges. So let me see if I can pick on one of these. How about if I pick on the first one? How about x over x over x squared minus 2, 1 to t. So 1 to t. Well, let's give it a shot. I hope we can do some anti-differentiation in our head. I hope we can do some substitutions in our head. Multiplying top by 2, divided by 2 on the outside, give me 1/2 on the outside. Looks to me like I have the natural log of x squared minus 2 from 1 to t. It should be absolute values. I'll put them in. So that give me this. Now, as t goes to 2 from who cares what side, this input right here goes to 0. That means the natural log is going to go to negative infinity. Don't I clearly diverge? Because with one of those integrals, I had divergence, then the entire integral diverges. So I guess in the end, those unbounded regions add up to an area which does not represent a finite fixed real number.